Alright, so then what was the success with it? Like, what was good about it? Children, I am asking you a question. If we don't need to go over any of these problems, then what was easy about it? Like, what was, like, what did you, tell me about your confidence.
It wasn't too easy, but it wasn't too hard.
Okay, so what do you feel like made it hard?
Big numbers, and you have to find like how many times like 83 goes into 277.
Okay, so one of the questions on the back, you had, when you changed your mixed numbers to improper fractions, you ended up with really big numbers, right?
Yeah.
Okay, why do we feel like that might be something that is hard to essentially divide? A very large number to a fairly, like, a 2 or 3 digit number. Why do you think that's hard? Jonathan, sit down.
So if there was a big number, it'd be harder to divide it by a smaller one because you would have to continuously like bring down the numbers.
Okay, so the long division part.
Yeah.
Alright, if you felt like this was super, super easy, tell me why. Camden?
I didn't do all of it because I forgot to.
Okay, so that made it super easy?
Yeah.
Fair enough. Alright, today we are going to be doing another open up lesson. And then we're gonna be doing a handout that essentially you're gonna be dealing with really big numbers because you're finding the number of cubes that fit inside of a 3-dimensional figure. So when you're doing your division, you're dealing with numbers that are in the thousands. And this is where volume gets difficult because we have to essentially do division with such big numbers. Alright, so if there are no other questions, go ahead, turn the page. Alright. Starting with our, it's not really our warm-up, it's just kind of our, we're jumping right in, there's no warm-up with this lesson today. So it says a box of cubes. So it says how many cubes with an edge length of 1 inch can fill this box? Now, this is my question. How do we find out how much space the 1 inch cube takes up? Because that's ultimately what you have to do. So how much space does a 1 inch cube with edge lengths of 1 make up? How do we find that? Or essentially, what do we have to find in order to get that answer? Christiana? Right, so we have to find the volume of that little cube. So here it tells us edge length of 1 inch. So essentially, if I have a cube, and this is 1 inch, this is 1 inch, and this is 1 inch, what do I use to find volume? What's the formula? Troy?
Length times width times height.
So if it's 1, 1, and 1, I'm gonna do 1 times 1 times 1 equals what? Equals 1. So this is 1 inch cube. So now I know how much volume that small cube is gonna take up. Now what do I have to do with this big cube that we're given measurements for? What do you have to do for the big cube, Jonathan?
Multiply length times width times height.
Right, because we have to find the volume of that one, right? So this one, I'm gonna do 4 times 10 times 3. So 4 times 10 is what?
40.
40. And 40 times 3 equals what? 40 times 3 equals, William?
140.
Alright, so the volume of this rectangular prism is 120 inches cubed. The volume of my small cube is how much? What is the volume of my small cube? Emily?
1 inches.
Right, 1 inch cube. So the question, we've done all this work and we still haven't got our answer yet, right? So the question is saying, how many cubes with an edge length of 1 inch fills this box? What do we have to do with 120 inches cubed and 1 inch cubed? Whatever you have to do with those two numbers to figure out how many cubes are gonna fit in there. Yeah, so we're gonna do 120 divided by 1 gives us what? It's not rocket science. Like, it's as simple as the question is. Christiana? So 120 cubes are gonna fill this box. Okay? So the process for finding the answer to questions like this is finding the volume of that small cube, finding the volume of the big cube, and then dividing those two. Alright? So it's a 3-step process. Down here, underneath your line, step 1, find volume of small cube. Step 2, find volume of big rectangular prism. And then step 3, divide volumes and get answer. Alright, stand up when you have that written down, please. Alright, so let's look at number 2. Number 2 says, if the cubes had an edge length of 2 inches, would more or fewer cubes be needed to fill the box? Alright, so the edge length has now increased to 2 inches. So, would the volume be getting bigger of the small cube? Because, I mean, think about it, 2 times 2 times 2 is what? Well, tell me 6. 2 times 2 times 2 is what? Can you then? 8. So the volume of each cube is 8. So we'd essentially do 120 divided by 8, which would give you more cubes or less cubes.
Did anybody bring pet food?
Put the scissors away, child. So again, if we divided 120 by 8, would we need 120 cubes to fill the box? Or would we need less cubes to fill the box? Someone other than Ronnie and Christiana. Kaya? Less cubes. So essentially your thinking should be bigger the volume of smaller cube. The less cubes that will be needed. Alright, number 3 says if the cubes had an edge length of ½ inch, would more or fewer cubes be needed to fill the box? Explain your reasoning. So now our edge length is ½ inch. So did it get bigger or did it get smaller? Aiden?
That's small.
Got smaller. So then are we gonna need more cubes or less cubes in one?
More cubes.
Why?
Because one half is less than one.
Right, so pretty much the exact same except for a few words. Smaller the volume of the smaller cubes. The more cubes that will be needed. Alright, give me a thumbs up when you have this written down. Alright, slide over to 15.2. So we're going to be talking about cubes with fractional edge length. So Diego currently points out that 108 cubes with an edge length of 1/3 are needed to fill a rectangular box that is 3 inches by 1 inch by 1 1/3 inch. Explain or show how this is true. You can draw a sketch if you want. So how do you think, why do you think this is true? How do you think we could show that? How do you think we could draw that, or show that, or explain it, or whatever?
If we divide the two fractions.
We can what?
If we divide the two fractions.
Okay, so we can do some division. Alright, but do we have to do something first before we divide? Delilah?
By the volume of small.
Okay, so we would essentially have to find the volume of a small cube. Alright, so 1/3 times 1/3 times 1/3 gives us what? Guys, this is easy. I should have almost every hand up right now. Alright, Troy?
1/9.
No. This is not 3 times 3. This is 3 times 3 times 3. Olivia?
1/27.
Alright. So, the process you guys are telling me is essentially we can go through and find the volume of this, and divide. That's fantastic. That's what we're gonna do here. Okay? What's another way that we can look at 3, 1, and 1 1/3? Looking at fractions. So I'm gonna draw a little box around this. So how many 1/3 essentially fit into 3? If I have 3 holes, how many 1/3 are gonna fit into there? Let me ask you this. How many 1/3 go into one hole? How many 1/3 go into one hole? Emma?
3.
3. So we have 3, and then if we have 3 holes, we're actually gonna end up, like this will be 9. There'll be 9 1/3 in that one. Alright, obviously in 1, how many 1/3 go into 1? How many 1/3 go into 1? Noah?
3.
And how many 1/3 go into 1 and 1/3? How many 1/3 go into 1 and 1/3? Mila?
4.
Alright, so I'm gonna do the math. 9 times 3 times 4. 9 times 3 times 4. Camden, what do you get, sweetie?
108.
108. So, does anybody understand what we actually did? Raise your hand if you're like, I have no idea where you truly got 9, 3, and 4. Thank you, Levi, for being honest. Alright, so if I have one hole right here, and my fractions are 1/3, I'm gonna break this into 3, right? So in this 9, how many 1/3 do I have in it? Or, I'm sorry, in this 3, how many 1/3 do I have in it? How many?
3.
Okay, so in this whole number 3, right here, whole number 3, if this is one hole right here, right? Does everybody understand? This is one hole. If I break one hole into thirds, how many thirds am I going to have into that one hole? Y'all, this is not rocket science. Get it together. Let's go, wake up. I know it's rainy outside. I know it's Thursday. It's been a long week. Let's go. This is not hard. Again, how many 1/3 is in this one hole right here? Kylie? 3. How many holes do I have in my problem? In this part? 3. So I'm going to do 3, 6, 9. That's where the 9 comes from because there's 9 1/3 in it. So this next one, if it's one hole, how many 1/3 do I have in it? How many 1/3? Elisa? 3. And then this next one, 1 and 1/3. So I have one hole, and then I have one teeny tiny little 1/3 right there. How many do I have in it? How many do I have in it? Emmeline? 4. So that is where I got 9, 3, and 4. That is another way that you can go about solving problems like this. You can say, okay, if they're 1/3 inches, and these are my numbers, I can see how many of my fractions will fit into each one of those. It's just another way, it's not the only way. Okay, so number 2 says, what is the volume in cubic inches of the rectangular prism? So now we have to find the volume of the rectangular prism. So we're gonna do 3 times 1 times 1 and 1/3. Can we multiply 3 times 1 times 1 and 1/3? Nope, so we have to put 3 over 1 times 1 over 1 times 1 and 1/3 becomes what? Kaya? 4/3. And then we multiply straight across. So 3 times 1, raise your hand. 3 times 1, Zoe? And then 3 times 4, Zoe? 12. Alright, and then 1 times 1, Olivia? 1 times 3. So 12 divided by 3 is going to give me what? 12 divided by 3 is going to give me what? Kyra? 4. So the volume of this is 4 inches cubed. So the volume of this cube right here is 4 inches cubed. Alright, so number 3 says Lynn and Noah are packing small cubes into a cube with an edge length of 1 and a half, goodness gracious, inches. Lynn is using cubes with an edge length of 1/2 inch, and Noah is using cubes with an edge length of 1/4 inch. Who would need more cubes to build a 1 1/2 inch cube? Alright, so stand up if you think it would be Lynn. She would need more cubes. Okay, stand up if you think it would be Noah. Alright, so everybody thinks it's Noah. Alright, have a seat. Why is it not Lynn? That's that. Why is it not Lynn? Jonathan?
The size of a cubic meters are bigger.
Right, because the size of the length of one of her cubes is bigger than Noah's, right? 1/2 is bigger than 1/4. Alright, so naturally we know Noah will need more because his edge length is smaller. Alright, the next question. If Lynn and Noah use their small cubes to find the volume of the 1 1/2 inch cube, would they get the same volume? Explain or show your reasoning. Alright, so think about this one. I'm going to give you about 30 seconds to think. You're not writing anything, you're just thinking. Alright, and then I'm going to give you a minute to talk to your table mates and see what you guys say. Would they get the same volume or no? Alright, so you have 1 minute, go. So So, with the few groups that I did stop and talk to, I heard that they're not gonna get the same volume. Is there anybody who said that they would get the same volume? Okay, so here's my question. Does the volume of the box or the cube that they're trying to find change? What is the edge length of that cube that they're trying to fill? What's the edge length? It's on your paper, so just look on your paper and then raise your hand. Zoe? It's 1 1/2. So regardless of the size of their cubes, what's the volume of the big cube? 1 1/2 times 1 1/2 times 1 1/2. Does the volume of the big cube change? No. So they're gonna get the same volume. Now, if the question asked, will they use the same number of cubes? Then your answer would be no. But the volume itself of the box, let's say that this was the cube that they are trying to fill, this is never gonna change, right? The number of cubes we put inside will change because we're gonna have different size cubes, but this cube will never change. Does that make sense? So the volume of the cube itself will not change. Alright, so they will get the same volume of the big cube. Alright, so we are done with the Open Up lesson for today. So you can go ahead and quickly glue that in. And then get out the piece of paper that I just passed out to you guys. Alright, if you have not titled the next blank left page, volume of fractional edges, please do so. Alright, so slide over to where it says exercise 1 through 5. Alright, I want you guys to cross off B, C, and D on this part. I don't want you to worry about doing those. You are going to be doing 1A though. Okay? So sliding back up to our first exercise, we are going to do this one together, and then you guys are going to be working not independently, you're going to be working with your group members. Alright, so it says which prism will hold more 1 inch by 1 inch by 1 inch cubes. Alright, so what is the process that we essentially have to do? What's the process that we have to do here? And if you're not sure, I'll give you a hint. You wrote it on the bottom of your first page that we did. Ronnie?
Determine the volume of the smaller cube.
Okay, so let's find the volume of the smaller cube first. So we're going to do 1 times 1 times 1, which gives us what? Delilah? Alright, so we have 1 inch cubed is the size of that small cube. Alright, then what does step number 2 tell us to do? Step number 2, what does it tell us to do, Christiana? Okay, so let's find the volume of this cube. So we do 10 times 4 times 6. So what is 10 times 4? You can just call it out. 40. And 40 times 6 equals what? So 240 inches cubed. And then this one over here, we're going to do 12 times 5 times 8. So what do we get when we do 12 times 5? 60 times 8. Okay. Alright, so we have found the volume of both of those cubes. Which one is going to hold more? The 220 or the 480? Question. Levi. The 480. So this one is going to hold more. Why? Why does that one hold more? Levi? Say, I just didn't hear you. Say that again. Because it has a bigger number. The volume has a bigger number.
Yeah.
And that's right, because the volume has a bigger number here, and the volume of our 1 inch cube is 1. So it's going to take how many 1 inch cubes to fill up 100 or 480 inch cubes? Camden? 480. Question. Or is that a call? Okay. Both. And then this one, if the volume of this one is 240, how many cubes is it going to take of that one? 240. Alright, so how many cubes will the prism hold? And we just discussed 480 cubes for that one. Okay? Does everybody understand that? Alright, are there any questions?
It says how much more cubes, so it's like 480
Yeah.
minus.
Yeah, I'm sorry. You're right.
Yeah,
I did this earlier when I was doing my answer key. So we have 480 here. We have 240 here. What do we have to do to find out how many more this one will hold? Sorry about that. Appreciate you guys keeping me on track. Kyra? So we're gonna have to subtract. So we're gonna do 480 minus 240, which gives us how much? Camden?
240.
Alright, so there are 240 more cubes. Alright, so you guys are going to be doing example number 1. It says a box with the same dimensions as the prism in the opening exercise will be used to ship miniature dice which or whose side length has been cut in half. The dice is half by half by half inch cubes. How many dice will fit in the size box? So we already know the volume of this box, right? Because it's the same one as the one up here. So what's the volume of this box? What's the volume? Olivia.
140 inches cubed.
Alright, so this is 240 inches cubed. What do you have to do to solve this problem? Because this is the same size cube as the first question? It's the same size cube as the first question. No, it says right here, the side lengths have been cut in half, so the new dimensions for the little dice are half by half by half. What do you have to do with half by half by half? Mila? You have to find the volume, so that is step number 1. So half times half times half. Stand up when you have your answer. Alright, Zoe, what did you get when you did half times half times half? One, yes. So 1/8 inch cubed. All right, so now what do we do with 240 and 1/8 inch cubed? What do we do? So we just found step number 1, we found the smaller cube, right? We already knew the bigger cube. So what is step number 3? What does it tell us to do? Again, you guys are reading off of your paper. I'm not asking you to do any math, I'm just simply asking you to tell me the step. What's the last step that we did? Emily?
Divide the two volumes.
All right, what do we have to put 240 over so that we can do this problem? Kyra? 1. All right, so we're gonna keep, change, flip. So 240 over 1 times 8 over 1. Stand up when you know what 240 times 8 equals. What do you get when you multiply 240 times 8? Delilah? So how many dice will fit into this cube, or this rectangular prism, sorry. How many dice will fit there? Jonathan?
1,000.
And that is your answer. So what do you think is so hard about finding fractional edges? You say no right now, but what, based off of this problem that we just did here, where do you think you're gonna come up and have a problem, if you're gonna have one? Ronnie, what do you think? The dividing part. All right, this part, because these are still nice numbers, right? But when you gotta multiply a 2-digit by a 3-digit and then go and turn around and divide it, that's where it's gonna get a little bit harder. Okay? So here's an example, kind of guided. You did some of the work, I did some of the work. You are doing example number 2 as a group. Flip your paper over. Number 2, A and B as a group. And number 3, A and B as a group. Okay? So you're doing the rest of this as a group together. If you do not finish this, it is homework. Take your paper, fold it, put it in your notebook. You are getting your cool down. As soon as you get your cool down, get started on it. Make sure you answer both questions. And then turn it in to